Okay, let's just move to the next session. The next session is on the title of Lessons from Launching an LLM Chatbot from Jake and Stelios from MQube. So Jake is a data scientist who has published research and is currently working at MQube with a focus on MarTech. And Stelios is the head of research at MQube, and he has a background in AI and computer science and is also interested in the overlap between AI and product. So please give a round of applause for Jake and Stelios.
Is this on? Oh, nice, very flattering. Thanks, guys. Yeah, I'm Jake. I'm the head of MarTech at MQube, and Stelios is our director of AI now. We had a little reshuffle earlier this year. So I'm going to talk to you about launching our latest chatbots. But first, I'll talk about who we are, who MQube is, and who we are. So MQube is a tech company in the loan origination space. We built out a platform that completely underwrites mortgages so that your experience in mortgages is more similar to the experience you'd have if you applied for a credit card or a car loan. And MPowered Mortgages is our lending arm. So we offer forward flow solutions to banks, building societies, investment banks, anybody with loads of money that wants to originate mortgage assets. OK. So we're here to talk to you about our GPT-4 chatbot, which is helping to resolve 43% of live chats without human intervention at MQube, and what we've learned whilst doing so. I'll talk to you briefly about the mortgage market, because sometimes it's complicated. So if you want an empowered mortgage, you have to go to a mortgage broker who's licensed, and they have to be registered with MPowered. So the only requirement is that they're licensed, and then they can register and apply for their applicant's mortgage through us. We've just over 12,000 brokers registered on our platform, and they're split between just over 1,600 firms, which is about half the market, I think. So there's multiple parts to being eligible for a mortgage. One of them is affordability. Another one's whether you fit the lending criteria. And the lending criteria broadly defines our risk appetite, but more so the risk appetite of the funders for whom we're providing forward flow solutions. So these are some examples of questions that you might be asked. And there's two ways of finding out this information. You can either go on our website and search for the residential lending criteria after yourself, or you can contact broker support, who are a small team we've got in Guildford, who will answer questions related to cases or criteria. So they get just over 1,000 calls a month and just over 500 chats through our chat service on our website. And roughly 50% of those questions are criteria related, which are usually very simple and present an opportunity for automation. So this is CriteriaGPT. It's a chatbot that takes some of our lending criteria, whatever the broker's asking, and responds with an accurate response. So you can see what this looks like here. You can play around with it as well. You can interact with it just as you would ChatGPT, but it's referencing our lending criteria. I've got some more examples here. This is more interesting. So what's exciting is it takes the tone of voice from the user and responds back. So you can see there it says, "Is that okay?" "No" is the first response. Here, you can ask who you can lend on, and you notice that it's providing the reference to the criteria that you saw earlier. And in this case, it's ingesting enough data to produce two different links to our criteria. So it's able to kind of compound different sources of information. OK, and here's our usage. So we launched on the 22nd week of this year, which was the first week of June, I think. And you can see how popular it's proving with with our brokers. They're getting instant answers to questions, whereas before they'd have to wait maybe 5 minutes to be connected with their broker support agent. Oh, Stelios, I'll hand over to you now to talk about how it's actually working.
Thank you. Is that on? This is on, huh? Is it too loud? Shall I? Is that okay?
It's great.
Perfect. Hi, everyone. Thank you very much for making it into the presentation. So I'll just go through. So this is, like Jake said, this is the impact it's had over the last few months. And just to tie in it to the beginning, so the average of that is 43, and that's 43% of all incoming chats being automated. So it's had a very big impact for us. So what I'll do for the rest of the presentation is I'll go into a bit more detail about how it works from a technical perspective, what the architecture is, and then over the last few months that we've had it live, what types of lessons we've learned from interacting with this architecture. So basically, we had our lending policy, and we have an LLM like GPT-4. So there are usually two ways to augment the LLM with your own private data. One way that all of you know about is the fine-tuning. So you take the LLM and then you fine-tune it on your private data, and basically it gets to be augmented with this extra information. The second way is this architecture, which is called a retrieval augmented generative architecture, for short RAG. So for the rest of the presentation, I'll be referring to this architecture as a RAG app. I won't go into details about comparing the benefits of fine-tuning versus doing a RAG app, but it's a very interesting topic in research, when you should use one and when you should use the others. So in short, a RAG app has 3 steps: the embedding step, the retrieval step, and the generative step. So this is all 3 of them in one picture, and then I'll go into more details about each one. So the embedding step happens at startup when you first build your API. And what it is, we've got, in the real world, we have a collection of documents in English. That's the lending policy. That's the pieces of information that Jake showed, which tell you that we don't lend on properties with a flat roof over 40%. So it's all English. And the embedding step is converting that into a set of vector embeddings. This is what we were doing a few years back with Word2Vec. Now with LLMs, most people have switched on to using pre-made embeddings like what you get from OpenAI or what you get from Cohere AI. So this step is essentially taking your entire knowledge base and converting it into a set of embeddings. And then I'll just go back to the previous slide for reference. So this is the incoming question. So this is a question exactly like that. Do you accept JPSP mortgages or properties with a flat roof? And just switch on between slides just for ease. So you'll see that this is our entire knowledge base, which in the embedded step has been converted into a set of embeddings. So a question comes in, and it's also the same embedding transformation is applied to it. And in the retrieval step, the whole database, the whole vector database of the embeddings is searched for to pick up the most relevant bit from the criteria. So I'll go back to where I was supposed to be. So this is it. Given the question, a search mechanism is applied on the embedding database, and the most relevant pieces of the criteria are picked up, which can be 5 documents, it can be 2 documents, it can be 10 documents. This all depends on your specific use case, how big its document is, how big the context length of its LLM is. For example, Claude has a 100K tokens context length, so that means that maybe you can get away with having bigger documents. So there is a lot of parameterization in this step, but in principle what it does is it finds the most relevant pieces of the knowledge base and just grabs them. So next step is the generative step. This is the output of the previous step. So this could be 5 pieces of lending criteria in our use case. And this is the actual incoming question. So as you can see, they're collated together into a single big prompt, which goes to an LLM, and this is the response. So in short, the first step is embedding our knowledge base into a set of vectors. The second step is, given a question, finding the most relevant pieces of criteria in the knowledge base. And the third step is taking them together and sending them to an LLM to get a response back. So this is the generic architecture of building a RAG app. And during we first launched the first beta version of CriteriaGPT in June. Now it's been live in production for 4 months now, and this is, you saw that earlier on the chart, on the graph that Jake presented with the automation rate across the different weeks. In this slide, for the rest of the presentation, I'll talk about 4 key lessons that we've learned during this process, and our hope is that all of those lessons are transferable across different applications. So if some of you work in law or insurance and you're building similar type of data augmented chatbots, this might be useful to you. So I'll go through each of the lessons one by one. So the first lesson is that all knowledge bases have gaps. So with the LLM craze over the last year or so, I've personally seen massive amounts of demos on the web about people building a chatbot on top of, let's say, The Great Gatsby, or on top of War and Peace, and then asking a question on top of this corpus of documents. This is a bit deceiving, because in real life, you have no guarantee that the knowledge base will actually have all the answers to the questions that the users are asking. So this brings a problem. And the problem is that if a user, especially in our setup, if a user asks a question and the answer is not in the knowledge base, the retrieval will still pick up 5 documents, let's say. This will go to the LLM in the generative step. But because the documents are irrelevant to the question, this increases the chances of hallucination. So the LLM might end up giving wrong responses and ultimately, in our setup, turning business away. So this is pretty risky. So I'll walk through these steps. Obviously, if you're not working at scale and you have maybe 1 or 2 questions a day, you can literally be sitting on the screen and watching over what the LLM says. But it's very important to have a way to pick up when a question is asked that doesn't exist in the database. So the 2 ways that people are doing this is either trying to identify that in the retrieval step or trying to identify it in the generative step. So in the retrieval step, and I didn't explain that earlier, but what happens is that when you find the most relevant pieces from the knowledge base, usually you're applying some sort of similarity check. A vector similarity check may be consigned similarity from the user question against the knowledge base. In principle, you would expect that the bigger the similarity, the most relevant the question is to the knowledge base. But in reality, this is not a good metric, and it only works for large gaps only. So I'll go back to an example that Jake showed. So over here, you can see a question that doesn't have an answer on the knowledge base. We don't have any specifics about astronauts. So this is a question that, when searched on the knowledge base, it might actually create might have a large gap and therefore a small similarity score. And just so that I don't go back to the slide, you will be able to see that CriteriaGPT over here says that the lending criteria does not have an answer to that, and then the customer can easily speak to broker support. So this method of relying on the similarity metric only works for large gaps, so very relevant questions. Now, what we've actually seen working better in practice and also working for small gaps is relying on GPT-4. But this step only works if it's GPT-4. So at first, when we were using GPT 3.5, because I couldn't get access to OpenAI to give me GPT-4, this was a massive problem for us. But just switching over to GPT-4 and Claude 2 solved this problem. So this is a problem with a solution, but it has to be a very strong LLM. So I'll move on to lesson 2. And now all of the rest of the 3 lessons rely around evaluation and how we felt confident to actually release this to our customers. Originally, this started as a research project for us to experiment, but over time, seeing good results, we decided to fully launch it. So what we did to see if we were confident to launch it is broker support has been answering chats for 2 years now, so we have a massive collection of ground truth data, questions from brokers, answers from broker support. So this serves as a historic ground truth set. And then the question is, fine, we've got them. We've got a chatbot that we don't know how good it works, but it does give answers to these questions, and now we want to know if these answers are correct or not. What we first thought of doing is kind of follow the standard machine learning approach, where we set up a very clear accuracy score, and then what we do in classification setups, and then try to measure that and have a way of going, this is 90%, this is 70%. The usual scores, the usual NLP metrics like Rouge or Bleu are used very much in tasks like Google translation, like machine translation. So at first we spent quite a lot of time in trying to adapt those to our setup. But we couldn't quite crack it. Sometimes we were getting very high scores for irrelevant responses, and we in generally didn't find them very easy to interpret. What is now emerging as an alternative and actually easiest and more reliable way to evaluate chatbots is again using a strong LLM to do your evaluation. In that case, GPT-4 again. This is actually used in the Vicuña paper and in QLoRa for just as some recent examples. So it's used more and more often in the industry. And this is literally taking the ground truth answers, what the chatbot has produced, and then asking another instance of GPT-4 to tell you whether the 2 answers agree. And then very easily you can come up with a total accuracy for your chatbot. But again, like previously, this has to be a GPT-4 model, which is very interesting. And this is basically how we evaluated our chatbot end-to-end. So that includes the entire RAG architecture. And this is how we felt confident that, yeah, we can fully release this and launch it to our full customer base. Lesson 3 is besides choosing the LLM, what LLM you'll use, something else that you get to control, obviously, in the generative step is the prompt. And that's the prompt engineering that we all know about. Crucially, with prompt engineering, you can control different aspects of the generation. For example, just to relate this to lesson 1, you can force GPT-4 to tell you, I don't know, if it doesn't know the answer. So this step is actually also controlled through prompt engineering. But you also get to control the user experience more. So for example, an LLM can structure its response in bullet points. Or it can try to be very concise and just give you a yes or no answer. Or it can try to walk you through its thinking and come up with a lengthier answer. And this is actually really important because what we're seeing so far in the last few months that we've had it live is that the 43% of chats being automated, I won't go back to the slide, but the 43% of chats being automated could be much higher if people trusted the chatbot more, because what we're seeing is that it's coming back with a correct response, but people still choose to reach out to broker support. So there is a user experience element here in the sense that they're asking a question, it's coming back with the right response, but for one reason or the other, maybe generative AI, it's still in its early days, and there is too much noise around and people don't trust it. But there is an element here that maybe if the answer was different, they would be relying on the chatbot more and not reaching out to customer support. So what we're doing over here is we're evaluating different prompt strategies to solve exactly this problem and measure the user experience impact it has. At first, we were trying to evaluate prompt engineering as part of the end-to-end evaluation over here. So an offline end-to-end evaluation using GPT-4 to also test different prompt strategies and maybe compare how the LLM's answer with this prompt was different to the broker support ground truth answer. But obviously, if you're doing this, you're just like making assumptions about how will people react to this type of prompt. So what's much better and obvious in retrospect is to A/B test different prompt strategies. So what we're doing is, live in production, we have at any given time 5, 10 different prompt strategies, and incoming questions get allocated to different prompts. So this is the experimentation setup. And then we're also keeping track for every incoming chat, some key metric that's relevant to us. And for this scenario, the key metric is whether people will choose to still reach out to a customer support officer. And this way, we find that, for example, organizing the response in bullets leads to 20% more chats closed automatically. That's success for us. And then I'll go to the last lesson, which is evaluating retrieval in isolation. So I'll just go to that slide. So this bit over here, the retrieval, is an independent component from this. Obviously, what's retrieved here affects this. But it's a closed, defined task where, given a question, there is a fixed set of answers containing the answer, a fixed set of documents containing the answer. So it's almost a missed opportunity if you don't evaluate this component on its own and instead rely on end-to-end evaluation for the entire architecture. I'll go into a bit more detail. about this step. Especially because the intelligence of the LLM is bound by the retrieval accuracy. So if you've given irrelevant documents to the LLM, it won't be able to come up with the right answer. And in my experience, most of the problems with RAG apps come in this step rather than the generative step. So what we did is we put together a ground truth set of just only for retrieval, where given a question, there is 1, 2, or 3, in some situations, documents that contain the answer to the question. And then we experimented with different retrieval mechanisms to see which one works best. So this is a flourishing area of research. I'll just walk through some examples for different retrieval mechanisms. Top K is basically just choosing how many documents you'll retrieve given a question. Will you try to retrieve the top 3, or will you try to retrieve the top 10? This sounds obvious, but if the knowledge base has very big articles where maybe putting 10 exceeds the context window of the LLM, that can be a problem. So you can't always go for a high K. And then on the other side, sometimes going for, let's say, a small K means that information that's spread across articles won't all be aggregated together for the LLM step. So this is a step, this is a parameter worth tuning around. So in this context, that's trying out different K values and choosing the best. Another approach is using some value of K, doing your retrieval, and then on top of it, taking those 5, 10 answers, whatever the value of K is, usually a big K in this setup, and using another LLM to do the re-ranking of them. So you take maybe the top 15K, you can go for a big K, and then ask an LLM to re-rank them and tell you this is the best, this is the second best, ignore everything else. But this is a question that needs to be answered in each different use case, because LLM calls, besides cost, also add a massive amount of latency. So that's an LLM call usually is about 10 to 15 seconds in our experience with GPT-4. So doing that means that your chatbot will take 30 seconds to respond, which is not ideal in many situations. So that's another mechanism. And this is also very, very interesting. It's using metadata on your knowledge base, which basically means doing the retrieval mechanism and doing the search not only on the actual text contained in the documents, but also on some additional metadata which may have come from different sources. For example, for us in MQube, we're a lender, so the public-facing criteria that Jake showed you is what the customer sees, but internally we have a different, more expanded knowledge base, which is very operational, contains many more details. It's 150 pages long. But crucially, we don't want it leaking to the user because it contains details about how we're doing our underwriting or how we check for financial crime. So these things are not things we want them being contained in the answer, but crucially, we can still use them to search for. So we're looking at the automated ways to expand the knowledge base with metadata, which can then be searched for in this step. And this can work really, really well. So it's definitely worth playing about. So this is it. I'll just do a summary of the 4 lessons learned. So the first lesson was that all knowledge bases have gaps, and having a way to identify them in scale is really important because you'll get to be updating your knowledge base over time and reduce those gaps. Lesson 2 is evaluating with GPT-4. Works great end-to-end, and it's probably more reliable and reproducible than using custom metrics. Number 3 is users don't trust chatbots yet. Try to evaluate, to A/B test different prompt strategies to see what works best for them. And the 4th step is evaluating the retrieval step in isolation is worth it, because this is where most RAG errors happen. This is it. Thank you very much for listening. We're on social media if you want to reach out. And this will take you to our website, where you can also test CriteriaGPT for yourself and see if what we've said are actually true or if the chatbot even exists. Thank you for listening. And just as a last note, we're hiring. There is a new person joining Jake's MarTech team. So if you're keen and all that sounds interesting, please reach out. Thank you very much.
Thank you, Jake and Stelios, for the wonderful presentation. We also have time for questions. There is at the back.
Hi. Yeah, with regards to your RAG pipeline, over here. Yeah, with regards to the RAG pipeline, have you, technically, are you using frameworks such as Haystack or Llama Index, or are you rolling your own abstractions? And if so, why?
So we're using Llama Index. We actually did a podcast with Jerry, who's running Llama Index as well. So we have a relationship with them. Llama Index has been super useful for us. So we used it originally for the demo, just on the original stages, because it takes like 5 minutes to put together a demo. But then we were really impressed with like the quality of the code, but also during all this like experimentation process, it was really useful as a community, but also as a documentation database of all the different methods. So it's basically got modules for everything that we've talked about. So we found it really useful, like, oh, there is this new method already implemented in Llama Index. So it really speeds up our whole process rather than us having to do anything from scratch.
Hello.
Hello.
This is Strong. So nice presentation. Thank you.
Thank you.
I was wondering if you reached the stage where you want to evaluate basically GPT-4, and where do you go with that? Because if you're evaluating weaker models, you can do it with GPT-4, but then when you reach that stage, do you have any ideas how to use, how to detect hallucinations or other problems for GPT-4?
Is that like when GPT-4 itself is might hallucinate?
Yeah, or if you're building systems with GPT-4 as your
Yeah.
primary LLM.
Yeah. So there are a few different angles for that. So in the RAG setup, I'm not sure if that's a question, but on the RAG setup, for example, we've seen very few hallucinations with GPT-4 when it's used in the generative step. And this is an area of research, obviously, but it looks like when GPT-4 has a fixed context, like try to answer this question given this context, it doesn't hallucinate as much. It hallucinates, obviously, if it gets asked to generate a generic answer on a topic. But when it's very focused in terms of the context, we're basically, this sounds very ambitious, but we're not seeing any hallucinations in production. So this is an aspect of RAG architectures, I think, that they're able to focus it on a specific context.
Hi. Thanks for the talk. I have a question regarding the LLMs. Have you tried, like, let's say, one LLM for generating the answer, let's say, ChatGPT-4, and another to evaluate or judge the answer, and the other way around as well? Yeah.
That's a very interesting question. 100%. So, for example, there is this step where in retrieval, or maybe that doesn't matter. In retrieval, where you can use re-rankings, where you can use an LLM re-ranking. So for that step, we've experimented with Claude. We've experimented with using Cohere re-rankings as well. So this is really interesting. And for example, Claude as well, in terms of the tone of style it has, it tends to be a bit more friendly and maybe a bit more professional than ChatGPT. So this changes over time as the LLMs change. But I think it's definitely worth like playing around with different LLMs.
Thank you.
Hi, I have a couple questions. So first, thanks for the talk, by the way. The first one is around UX. How do you know the call is the chat is resolved not just due to the abandonment of the chat? And then wondering, how do you escalate that to a human agent? Is it just a button always present on your interface that you can do that? Second question is like around, I can imagine if it's like a short one turn or 2-turn conversation that you actually end up having a lot of similar answers. Have you guys tried, like you have a proof answer database, you just do a search first, find a similar answer, then you avoid the generation altogether? Yeah, those two questions. Thank you.
Perfect. I'll take the second one, but Jake, do you want to take the first one?
Yeah, so the chatbot works through our CRM, so there's feedback options at the end of the chat, so once you get a response, there's some feedback options. But yeah, that's a problem we're facing, that if people abandon the chat once they've got a response from CriteriaGPT, I mean, we don't know if it has resolved it, we're just assuming that it has resolved the question. They can continue to give feedback and say that it resolved their query, but we don't know. I mean, most people don't use that. They get an answer and then they abandon the chat.
And the second question about using ready-made answers, it's really good. So that's something you can actually, we're using as metadata on the retrieval step. So that means you have the document in the lending policy, and then you can attach on it frequently asked questions as metadata. So when a new question comes in, this means that like the retrieval success will be 100% because basically the answer, the question itself is already in the document. This won't show up to the user, but it will massively help the retrieval step, and you'll be able to use frequently asked questions to improve your pipeline.
Hi, thanks. Great talk. I'm interested in performance in terms of impact on your current architecture versus where you might go in the future. So are you currently using everything via APIs? Are you running anything in your own infrastructure? Yeah, just maybe a bit of an overview of what it looks like now and where you might go in the future and how that impacts performance on latency with user interactions.
Yeah, 100%. The latency, I'll start from that. The latency point is a really good one. GPT-4 sometimes takes over 20 seconds to get back, which is a problem because the CRM interface that we're using for our live chat has a 20-second window. So that's a bit annoying, and it means that basically it stops us from doing multiple LLM calls in terms of the architecture just because of the latency. So going forward, like having your own LLM where you can do inference super fast, like hosting it on-prem could be super interesting. In terms of like us going forward, we're experimenting not so much with changing the architecture, which is at the moment an API that the CRM pings and gets back the response, but with expanding it to convert this to an agent within the CRM. So our chat flow is that like the user goes and then they still get to choose the specific route they want to go in. But over time, we want to move to a chatbot, to an agent functionality. Would you like to add anything on that?
Hello. Thanks for the presentation. I'm here. two questions actually. So the first one is around prompt engineering. Obviously, it's a increasingly important area. How do we structure our prompts to interact with LLMs so that you get the outcome desired? I'm just curious, how do you go about designing the prompt so you get the outcome? Is it more like an art rather than a science? And my second question was around more so open source LLMs. I guess right now you're using it for or maybe like not existing customers who are asking about mortgages and stuff. But do you plan to use this for existing customers where they already have a mortgage, they have questions about their mortgage that they're interested in? And then how do you tackle like GDPR concerns around that if they're querying themselves? Because I work in insurance, and when we talk about ChatGPT, it's sort of like a no-go area because you're leaking your customers' data to an API third party. So sort of two questions there. Thank you.
Thank you. These are really good questions. We spent a lot of time, so I'll start from the end with GDPR. We haven't included it here, but we have an anonymization component that Jake and me have spent a lot of time on. So we just didn't want to expand the presentation, but we have, besides the usual regex type of checks, we also have a small BERT that does NER and picks up in the user question personal data. Let's say if the broker, who's the user of this, includes information about the customer, GDPR is really stringent on data leaving the UK to go to the US, which is where OpenAI servers are hosted at the moment. So we've had to add this anonymization component just for the sake of GDPR. And then for the prompt bit, it's definitely an art, but it's also like, it stems from the use case. Like, we've spent a lot of time on the prompt engineering side making sure that it says, I don't know, or that this information doesn't exist on the lending policy. And then there's the whole aspect of like, how will the answer be formatted? Will it be short? Will it be quick? But this, I suppose, depends on your different use cases, how you want it to look like. But in general, like it's obviously an art, but maybe not as massive, I think, as people say it. Like it tends to respond reasonably well to small prompts, in my experience.
So if you have any more questions, you can reach to Jake and Stelios in the break or in the networking event. And thank you again for the presentation. So next is our lunch break at 12:30. So hot food will be served over there, and it's for 45 minutes. Thank you all.